of the, now it's being recorded, of the Scientific Advisory Committee. As Elka said, we will be recording this call, so please keep your microphones muted unless you're speaking, to keep down the background noise if necessary. And at this point, Ms. Taylor, would you please do a roll call to confirm there is a quorum present?
Okay. Maureen Bottrell.
I'm here.
Dr. Edinburgh.
I'm here.
Dr. Levine.
Here.
Rich Myers.
Here.
Jamie St. Clair.
Here.
Okay, Mr. Chairman, we have a quorum.
Thank you, Ms. Taylor. The first order of business is the adoption of the agenda for the meeting. You should have a copy of the draft agenda. Did anyone not see it? Silence is assent. I will need to ask a motion to adopt the draft agenda, but I will remind you when making a motion, because we can't see you, please state your name and that you are seconding the motion. Can I get a motion to adopt the draft agenda?
This is Jamie, and I move to adopt the agenda.
This is Barry, and I second.
Thank you. Any discussion? Hearing none. Ms. Taylor, will you take a roll call to record the votes, please?
All right. Maureen.
Aye.
Dr. Edinburgh.
Aye.
Dr. Levine.
Aye.
Rich.
Aye.
Jamie.
Aye.
Okay, the motion passes.
All right. The next order of business will be the approval of the draft minutes from the May 7, 2019 meeting. Just seemed like yesterday. We need, Ms. Taylor previously sent a link to the draft minutes. Are there any proposed changes to the minutes? Hearing none, I will assume there are none. I will ask for a motion to approve the draft minutes.
Rich Myers, move to approve the draft minutes.
Second, please.
Maureen, I second.
Barry, I'll second.
I think Maureen got in there first.
That's no problem.
Ms. Taylor, please take a roll call vote.
All right. Maureen.
Aye.
Dr. Edinburgh.
Aye.
Dr. Levine.
Aye.
Rich.
Aye.
Jamie.
Aye.
Okay, the motion passes.
Thank you, Ms. Taylor. The meeting minutes have been approved. We're now going to discuss the validations that everyone should have got a summary of. And we're going to review it. We'll provide comments or make recommendations. I will now turn it over to Dr. Hutchings and Dr. Wagner to lead the discussion.
Good afternoon, everybody, and nice seeing a few of you again from our earlier meeting. The plan is that I will give a brief synopsis of each one of the methods that was sent to you. And once I am finished giving the brief synopsis, then you can ask any questions or give any recommendations prior to moving to the next validation. The first validation that we are going to talk about is the non-steroidal anti-inflammatory drugs validation summary. This method was a transfer of our previous HPLC DAD method to LC-MSMS. The specimen requirements for this method is 0.1 milliliters of blood, fluid, or tissue homogenate. For analysis, something to note for the tissue homogenate, the homogenated should be centrifuged at approximately 2,500 RPMs for 15 minutes prior to aliquoting the supernatant for analysis to help with ionization suppression with the extraction itself. The extraction is a liquid-liquid extraction using hexane ethyl acetate at a 50-50 mixture. The target compounds include acetaminophen, salicylic acid, naproxen, and ibuprofen with all matched internal standards. Another item to note with this method and this validation summary, which was extensive given that we validated a high dynamic range and a low dynamic range method. So there are two separate working ranges, a 10 to 400 milligram per liter and a 1 to 10 milligram per liter for the working range for the low. This was because we were unable to validate an entire working range of 1 to 400 milligrams per liter. They have different reconstitution volumes at the end of the extraction once the samples are evaporated to dryness. The high dynamic range method is reconstituted in 400 microliters, where the low dynamic range method is reconstituted in 50 microliters. A few things to note with the validation: that accuracy and precision was performed in blank blood, postmortem blood, and liver using a blood calibration curve. The acetaminophen was quadratic weighted 1/x for the high dynamic range method, and all other compounds for both ranges was determined to be linear 1/x weighting. Interferences. During the evaluation of interferences, there was some difficulties with the low dynamic range to obtain matrices that were truly void of the compounds themselves. As I'm sure you know, salicylic acid in urine in particular was a response in most samples of about 30% of the lowest calibrator, which can just be from consuming green vegetables. And therefore, we naturally had difficulties finding any sort of truly blank specimens for our interference studies. There were the response of salicylic acid in urine, which I said was about 30% of the lowest calibrator, was the largest instrumental response that we did see. Everything else was significantly low, but it was identified as a peak with good peak shape and could be confirmed. Does anyone have any questions about that method and that validation summary?
I have one question. Did you look at any other non-steroidals?
No, not at this time.
Okay.
When I was reading through it, it was on page, I think, 22. You talk about, you were talking about robustness. And maybe I read this wrong, but it just says that you did a robustness test, but I didn't see any of the results for that.
So the validation itself was performed with both the low and high dynamic range for accuracy and precision for all compounds with multiple different instruments in our different instrument models. So the entire validation was part of our, I guess, in ways, our robustness testing.
Okay.
This is Jamie. Could I just generally, how many LCMSs, MSs do you have? Do you have them in every lab or just the central lab?
So
So as far as the LCMS, MSs go, we have, this is Dr. Hutchings, sorry. We have at a minimum 3 in each lab. We have a 60 model 6430, 6460, and 6470 in each laboratory. When we conducted this validation, you see it's only on the 6430 and 6460s. We just recently obtained the 6470s.
So what, did the validation then take place in all the different labs that have the different instruments, and were all the different instruments included then in the validation, other than your brand new one?
The validations for this method took place in our research section, which has the exact same models, the 6430 and 6460 that we have in all of the regional laboratories.
So then did you verify that it would work in your other laboratories as well?
Yes, when this validation goes out to each laboratory, they have to perform a verification, and we maintain that documentation.
Great, thank you.
Are you going to be doing any? Are you going to be doing any of this stuff with the new instrument you got? I think of the 6470. I think that was the number. Since we know that there's a difference in response from the two that we have, are you going to check out the third and see if that is also different?
Yes, so if they go to use this method on a different instrument, they will perform the verification on that instrument. But this method is unique that it is actually only being performed in our central laboratory at this time, although that doesn't exclude the other laboratories from being able to perform the method. It is a method that does not get utilized very often, and therefore currently the central Richmond laboratory is the only one that has performed the verification and can perform the testing.
But it's in the central lab. Well, is it the central lab, but you have the third instrument as well?
Yes, we have all of those instruments in all of the laboratories, and they have it. And if, like Dr. Wagner said, if we're going to utilize it on that instrument, they'll have to perform a verification on there. It just depends on the laboratory how they set it up. They may not perform all methods on all instruments. Maybe one instrument set aside to perform this method versus one of the other instruments. Off the top of my head, I don't know exactly how they have it set up as far as which instrument to use, because that's going to be determined by just efficiency within the laboratory.
The other thing I wanted to ask about was when I was reading through your limit of detection, it doesn't sound like you actually found the limit of detection. It sounds like you've got, I mean, that it works for the lowest level that you tested, but that you didn't go farther to find out what your actual limit of detection is. Am I reading that correctly?
I apologize. We might have frozen here where we are. Could you please repeat that question?
No worries. I was asking about your limit of detection. So when I read through this result, it doesn't sound like you actually found your limit of detection. It sounds like the lowest thing that you tested worked, but that the limit of detection is probably actually below that. Is that an accurate read that impression that I'm getting from reading?
Yes, there's certain methods where we can probably go much lower by the instrumentation and by the methodology. It's just that it becomes toxicologically insignificant to go that low. So we just sort of set a spot where it's administratively determined to be low enough for our purposes.
Well, it's your call on this, but I might, if it were me, I might make that explicit in the actual document, that you actually expect that the real limit of detection is lower, but that you're setting it at this point. That way you eliminate questions about whether or not you're bumping up against your limit of detection when you're down there measuring something.
I would add, I think it matters because not so much with this one, but when we get to the GHB, whereas I read it, your cutoff is 30, but you're having your limit of detection is 10, and in your carryover, you actually allow up to that as carryover, and so that would be 9.9, let's say. And if your analytical or reporting cutoff is 30 and you allow a plus or minus 20% variation, you could have carryover and fold it into another sample and not count it and not see it, because you really haven't seen how low you can go with the carryover that you're seeing or not seeing. I think that's to the point that we're making.
So if I could just, for this is Becky speaking, to clarify that it would be your recommendation to actually determine the instrumental limit of detection, and then we could probably roll in the instrumental limit of quantitation as well, although that may be different from anything that we would implement within the laboratory.
Yes, I think that's what we're saying, because usually what you like to see is if you're, let's call it your low reporting limit is 30, you like to have your LOQ at 15. So you have plenty of room in there that you can demonstrate you are identifying where you're reporting every time. If you imagine the results are 50% on one side of the cutoff and 50% of the other, by having that lower calibrator, 50% lower, you're ensuring your analytical work is good. And then we're saying, once you get down to LOQ, what's your true LOD? Because further into the validation, carryover is dependent on what you're calling your LOD, yet you're saying the LOD only has to be this because it's not clinically relevant. Well, that's not necessarily true when you talk about reporting something that may not have been reported before as below the cutoff, but carryover pushed it over. And then when you're doing mass spec, if you have something where the ion ratios are very large, you can contribute a lot to the quantitative ion and not throw out the ion ratios out of your plus or minus 20%. So again, you may have something that's carrying over and you say, well, I'll pick it up, or this is even an interference, I'll pick it up and see it, but you won't always, depending upon how your ion ratios are. If they're very small, yeah, you'll probably pick it up because the range is narrow, but if it's higher, like you have an 80% ion ratio, you're going 20%, that's plus or minus 16. That gives you a lot of stuff you could throw in there. And I just agree that you should really experimentally determine what the true LOD is. Does that make sense?
Yes, thank you very much.
And then the other question I was asked, this is your validation, that's fine, but what's your actual carryover criteria you use in practice in the SOPs? And I think I brought this up before, and a long time down the road. So what's the actual procedure in the laboratory when something exceeds the upper limit you've established?
So I'm trying to bring up our SOP on my computer to look at it. This is Dr. Hutchings. But we have recently changed from the last time we had this discussion. We've changed our SOPs as far as addressing negative controls and carryover. And anything that would be considered contributory, it has to have a signal strength that's 10% of what we used to call it LOD, but now because they're administratively chosen sort of cutoffs, we call it then our threshold control. And so that we're not saying that 10% of that signal when you run that threshold control in your batch is considered carryover at that point. So the idea being, if your threshold control for, pick a target, acetaminophen we'll say, is 30,000 counts, then 3,000 counts is sort of that limit of anything below that's not considered carryover. Anything above that that can confirm as acetaminophen would be considered carryover at that point. And then you have to address it at that point. But as far as if you have anything that's above your upper limit, if the sample following has that compound in it, you have to rerun it, re-inject it to assess did that carry over into it, and rerun that sample that was after that one that had that high concentration sample in it. Does that make sense?
Okay. Yeah. Okay, any other, and we sort of cast a wide net, but I think there were general comments about both. Any other thing you want to add about the non-steroidals?
Okay, on this one, this is one of the ones where I did have some typographical errors. So
Okay.
let's see. The first one is on page 2. About halfway down the page, you're talking at the second line of that paragraph. It says target compounds at 3 concentrations in triplicated ED. It should just be in triplicate.
Thank you.
That same typo is on page 3 of 56 at the bottom of the page, about 3-4 lines up from the bottom of the page. And let's see, on 21 and 22, you have 2 charts, and the charts are identified as chart 1 and chart 2. They should actually be charts 3 and chart 4.
Thank you.
That's it for that one.
Before then we leave the non-steroids, Barry, you had made a comment about testing other non-steroidals for interferences.
Yeah.
Do you have a suggestion, a comment, or are you fine just with the answer of no?
I'm fine with the answer. I was just wondering whether there are other non-steroidals, because the non-steroidals will have all kind of different structures, each one of them, and I was just wondering whether they had been checked. No, I'm good with what they did.
Okay. All right. Anything else on the non-steroidals? All right, Dr. Hutchings and Dr. Wagner, the next one.
Okay, so the next validation summary that we will talk about is GHB by LCMSMS. This is another transferring of an existing method. This method was a GCMS method to LCMSMS. This method is unique in that it separates GHB and GBL, and additionally looks for 1,4-butane-dione. The blood or the sample size is 0.2 milliliters of biological matrix. And it's a protein precipitation in acidic methanol, which is 1 milliliter total volume. It is a simple vortex and centrifuge prior to transferring 10 microliters of the supernatant and diluting it with 100 microliters of 0.1% formic acid in water. The dynamic range for this method, as Dr. Edinburgh had mentioned before, goes down to 30 milligrams per liter up to 300 milligrams per liter. Within this validation, we had both blood and urine calibration curves to be able to quantitatively evaluate urine, which is unique in all of our other methods. We do not quantitatively evaluate urine. Some challenges within the validation are naturally the endogenous GHB, and then additionally interconversion of GHB to GBL and GBL to GHB. We did an extensive evaluation on these interconversions to make sure that there is consistency of the interconversion within the electrospray ionization source. GHB to GBL was determined to be consistent between all matrix types and all instrumentation evaluated within the validation. And then GBL to GHB had an overall interconversion of GBL to GHB about 49 plus or minus 9%, with evaluating 366 samples. So that is something that is a unique challenge, as many of you know, with GHB evaluation, but hopefully we can answer any questions or concerns that you might have at this time.
This is Barry. I had a couple of questions. One, when you're making up calibrators, are you making them up separately? Are you mixing GBL and GHB in the same calibrator?
We are mixing them together in the same calibrator, and we actually are making them in acidic methanol as well. And then we did a stability study of our standard solutions to ensure that there was no interconversion that was occurring.
But aren't you getting interconversion within the instrument?
We are, but it's a consistent interconversion. Even if I analyze, we're not getting interconversion from the standard solution itself. If we just evaluate GHB by itself and evaluate GBL by itself, since we're chromatographically separated, we can tell which interconversion is contributed from which compound.
Do most of your samples, your real samples, have both GHB and GBL in them?
Typically, they'll just have GHB in them.
One thing to note as far as implementation of this method, we have made it where GBL is only qualitative. GHB and 1,4-butanediol are quantitative.
This is Maureen. My only comment is that this one also has the, just for the record, that this one also has the LOD issue.
Yes, ma'am.
All right, any other comments? All right, next validation.
Okay, so the next thing that we will talk about, if it is okay by everyone to speak on the Hamilton verification plan and summary, I will give a synopsis of that project since you guys have both the plan and the summary, and then we can kind of discuss both.
Yeah.
That's fine with me.
Yeah.
Perfect. Thank you so much. So we, as a department, have obtained the Hamilton STAR automated liquid handling systems, and therefore we had previously validated, and I believe maybe this subcommittee has reviewed or another subcommittee has reviewed the validation of our opioid and cocaine method. We had previously validated a solid phase extraction and a protein precipitation quantitative methods for the evaluation of opioids and cocaine. We then decided to take that previously validated solid phase extraction method and program our Hamilton automated liquid handler to perform that extraction for us. Therefore, it was more of a verification as opposed to a validation. And that verification was a twofold process. Once we were able to program the instrumentation and appropriately lay out the instrument. So there are some non-instrumental parameters, and then what I've designated as instrumental experiments that were performed. For the non-instrumental, those were all parameters that were evaluated that did not get analyzed on the LCMSMS, and they were just to show how the Hamilton was functioning, and that was to evaluate several different matrices and different matrix types to ensure that the automated process would be able to handle the variety of samples that we obtain within the laboratory and are submitted to us, including antemortem, postmortem, blood samples, but then also liver homogenates as well. During this process, we were able to fine-tune the method to note that our down to the bore size of the tip for the instrument to be able to aspirate up our biological matrix and successfully transfer it to the solid phase extraction column on the instrument. We also have noted that the sample aliquoting before it goes onto the instrument itself is a 1 milliliter aliquot. That sample must be aliquoted using a positive displacement calibrated pipette. And in that process, in the procedures manual, it denotes that it must be a smooth aspiration of the sample. In the best words to describe it, if it is chunky or hesitant when aspirating, that is a significant indication that the Hamilton system itself will not be able to successfully aspirate that sample, given the bore size on our positive displacement pipette tip and the bore size of the Hamilton pipette tip. Therefore, the samples can be poured off and aspirated and obtain a smooth aliquot for the Hamilton system. Another thing that you may be wondering is about tissue homogenates, because that would be a naturally very chunky, for lack of a better word, sample. And therefore, there's an additional step that has been put into the procedure to help mitigate the nature of those samples, which is aliquoting your 1 milliliter aliquot. After the buffer is added and water, centrifugation occurs, and that occurs with all samples. But then prior to putting onto the Hamilton instrument, there is a transfer step where the supernatant is transferred to a secondary container and then put onto the Hamilton system. And this ensures that that sample then can be aspirated by the instrument itself. So then we were able to perform a verification on the instrumentals to ensure that this method is working the same as it would from a manual extraction. So accuracy and precision was evaluated, a comparison between our existing manual extraction, and this extraction was performed carryover and cross-contamination. So this carryover and cross-contamination is more from the various wells and various steps within the extraction process itself, in addition to within the channels of the robot that are used to aspirate samples and solvents. A snap cap stability study, and then also looking at the stability of the eluate. Since the eluate is noted to be prepared fresh daily, we wanted to ensure that if it is sitting in the trough of the instrument itself, that additional evaporation wasn't occurring to then change the stability of that eluate itself. Does anybody have any questions about our plan and or summary?
I don't have a question about the plan for the summary nonetheless. But outside of the validation of the precision and accuracy, do you do a quarterly or semi-annually verification of the pipetting that the Hamilton does, either gravimetrically or spectrophotometry, to make sure it's delivering the right volumes?
So yes, we have preventative maintenance that happens every 6 months. And then additionally, the instrument has a software called TADM that I don't know if you are familiar with or not, but this software is a pressure tracing software that will indicate if the volume is not pipetted appropriately. So what we actually have designed too is that if we don't successfully aspirate a sample, instead of the system just stopping and screaming an error at you, it will denote at the end of the extraction on a batch sheet and a layout of the sample placement how much of each sample was successfully aspirated, the volume, and if there were any problems indicated during the process.
Okay, so Hamilton does your semi-annual actual test to ensure it's pipetting correctly, which you have documentation of. And then additionally, you're running TADMs, which I'm quite familiar with, and that's a good thing. That is actually a sample batch to batch, and that output is available to the technologist running the test.
Yes, that is correct.
Okay. All right. Thank you. That's the only question I had. All right. No comments on the Hamilton verification plan or verification summary? All right.
I have none.
I do have one typo.
Okay, go ahead, Marie.
Actually, on the first page where you're giving the page 1 of 6, where you're doing the summation, there in the non-instrumental experiments, you actually have a section G, which is evaluation of extraction process, and that's just not on your list.
Okay, thank you.
All right, very good. Whatever one you want to do next.
Okay. We will move forward to the fentanyl derivative quantitation plan by LCMSMS. This is a validation plan. It is not the validation summary for this method. As you have reviewed previously, the fentanyl derivative qualitative validation that we have performed and have had online for quite some time now. It is taking those fentanyl derivatives, which include 32 fentanyl derivatives, and we have added another fentanyl derivative, choroidinol fentanyl, and we are quantitatively evaluating all 33 compounds in a biological matrix using solid phase extraction. The hope would naturally be to, with this solid phase extraction, to then in the future verify it on the Hamilton system, and therefore it can be automated so that it would free up some of our examiners' time. So this is hopefully pretty familiar validation plan, similar structure to ones that we have presented in the past. Does anyone have any questions?
I have a question for Jim. How many of these fentanyls are you actually seeing in biological specimens?
Looking at our tracking chart, we kind of track our results as we're seeing it. It's in the last 6 months, it's kind of reduced down to just fentanyl, acetylfentanyl, and I think randomly the 4-ANPP, which is just a derivative, the metabolite. So we're not really seeing as many, but there was a different landscape when we started the planning out this method and planning out the grant for this. So we're kind of moving forward on this based off of grant funding and projects we had planned out.
Mm-hmm. Yeah, I can tell you in Maryland, the only ones we're seeing besides fentanyl and acetylfentanyl is the 4-fluoroisobutyryl and the acrylfentanyl. Those are the only ones that we're seeing, and fortunately, we're always seeing fentanyl.
Yeah, we see fentanyl pretty consistently, and yeah, like I said, the acetyl fentanyl kind of pops in here and there, but it's generally just fentanyl mostly nowadays.
Yeah. Okay. Thank you.
All right. No further comments
I just have one question in this one. So on page 3, under the accuracy and precision, it says under equation 1, I know what I think you want to say, but it says accuracy should be as low as possible. Is all the other documents in the actual documents, it just says that the accuracy should be within plus or minus 20% as the target. Should we just say that here? It sounds, I don't know, to say the accuracy should be as low as possible just doesn't sound right. I get it's a percentage and all that, but if the target is a target, then just say should not exceed 20%, plus or minus 3%. Is that a tox thing, or am I missing something?
No, I don't think it's a tox thing. I think it's more of a dependent upon how the data is presented. You know, if you're looking at, say, reporting it as just bias, 0 or plus or minus 20% type of a thing. Here it's probably just, we just probably wrote it incorrectly and maybe we just correct it in the future.
Yeah. Okay.
All right. And are we at the last one now?
We are, I believe.
Drum roll, please.
This is the fentanyl derivative SPE, so for our solid phase extraction qualitative validation plan. So as I mentioned in our last method, for our quantitative method, we have the previously validated qualitative fentanyl derivative method, which is a protein precipitation, which is our opioid and cocaine extraction. In moving the opioid and cocaine extraction to the Hamilton, we therefore needed to validate the solid phase extraction procedure with our fentanyl derivatives so that we could do all analyses simultaneously and reduce the amount of sample used and save some time and increase our efficiency within the laboratory. So therefore, we have a plan set forth to validate that previously validated opioid and cocaine solid phase extraction procedure for the fentanyl derivatives in a qualitative manner, and then transfer that to the Hamilton system. So this validation will be performed both with the Hamilton and manually within our validation itself, to assist in making the validation more rapid, but then also using all techniques within the laboratory that will be available to the scientists. Are there any questions?
Any questions? Okay. Hearing none, the recommendation that I jotted down was the recommendation to experimentally determine the limit of detection of each method presented versus using an administrative concentration. Are there any other additional recommendations? Hearing none, a rule of procedure question: do we need to have a motion for the recommendation, or just include it as a recommendation for closing the review? Or am I on my own? You're going to let me make the rules?
Wes, this is Katja. Can you ask that question again?
Yeah, so we have this one recommendation concerning experimentally determine the limit of detection of each method versus using an administratively determined concentration. Before I close the review, does that recommendation need to be put forth as a motion, or can it be added to a motion to close the review with that recommendation?
You could probably do it either way.
Super-de duper. So in the interest of saving time and words, echo wordism, I call it, can I get a motion to close the review of the validation with the recommendation to experimentally determine the limit of detection of each method presented versus using an established administrative concentration? I think a name and so moved would work.
This is Maureen. So moved.
Second,
Jamie,
please.
Jamie, second.
Any further discussion?
Yes, this is Barry. If I were to not think it was necessary for them to experimentally determine all of the LODs and LOQs, but feel what they have done is acceptable, would I vote no in this motion?
That means you have
My
to
answer
separate
to
it out.
yeah, then we should separate it out. Well, let me ask you this, Barry.
Yeah.
Are you opposed to the recommendation?
I don't think it's necessary. I think it's up to them. I don't have a problem with what they've done on these methods.
So then you are opposed to the recommendation?
Yes.
All right. I'm not sure what the right terminology is here. We will table the initial.
Excuse me, this is Katja. If you could, maybe Maureen, if you could withdraw that motion and then make a new motion.
Okay, I withdraw that motion.
Thank you.
So then what I need then is a motion for a recommendation to experimentally determine the limit of detection of each method presented versus using an administratively determined concentration.
This is Maureen. So moved.
Second?
Rich Myers, I'll second.
Barry, would you like to discuss, or you just
No,
want to move to a vote?
Yeah, I would move it to a vote. I've already said what I've wanted to say.
Okay, with no further discussion, then Ms. Taylor, could you call a roll call vote on the recommendation?
Okay, Maureen,
Aye.
Dr. Edinburgh,
Aye.
Dr. Levine,
No.
Rich,
Aye.
Jamie,
Aye.
the motion passes.
Therefore, the recommendation will be included in the summary of the review of the validations. Excuse me, can I now have a motion to close the review of the validations?
I make the motion.
Second. Thank you. For no further discussion, Ms. Taylor, please call a roll call.
All right, Maureen,
Aye.
Dr. Edinburgh,
Aye.
Dr. Levine,
Aye.
Rich,
Aye.
Jamie,
Aye.
the motion passes.
All right. Next item on the agenda is the discussion of methods in development. And once again, back to Dr. Hutchings and Dr. Wagner.
This is Dr. Hutchings. Just want to discuss these methods, and these are all kind of ideas in development at this point, and we're trying to sort of pave our path to figure out where we want to go with our limited resources and time. The first project we're looking at is transitioning their barbiturates quantitation from a current gas chromatography mass spectrometry method to the LC tandem mass spec. This one would require 1 milliliter biological matrix, and we're looking at pretty much recreating the current panel we have with a couple of compounds removed. Does anybody have any questions on our approach to this?
Is this just barbiturates? This is Barry. Is this just barbiturates, or does this include a bunch of anticonvulsants as well?
No, this is just barbiturates. We are just replacing the methodology that we have currently in our manual. We're trying to transition a lot of our older methods, so this is kind of one of the last few that we have hanging on to transition from GC mass spec to LC.
Okay, thank you.
I mean, kind of following up on your question, Barry, we do already have a method for anti-epileptics, anticonvulsants in our procedures manual that we validated a number of years ago.
Oh, okay.
And so Barry, too, the extraction that we're looking at doing with this is the same extraction as those anti-epileptic drugs, except for we will have to be using negative ionization mode for the instrument instead of positive.
Right. Okay.
Does anybody have any more questions on the barbiturates? No. Okay.
Hearing none, progress onward.
All right. The next one is the cannabinoids extraction by automated liquid handling system. So this one is a grant-funded project we're trying to explore. We're trying to look at updating our cannabinoids extraction method. And that one was validated nearly a decade ago at this point. And so we're trying to look at being one that's the more commonly abused drug in DUID cases. We want to try to put it into the more efficient process of using the Hamilton system. However, one of the tricks has been always cannabinoids are difficult with solid phase extractions. We want to explore a variety of solid phase extraction matrices and also look at some different ionization techniques in this system, in the LCMS systems. Again, this is grant funded, so this may be something that we want to do, but if we don't get the grant funding, we're not going to be able to do it. So does anybody have any questions?
That sounds significantly vague to leave lots of options available. So
yeah, it's pretty broad ranging as far as the different techniques we're looking at, and also we were looking at possibility of adding in some of the other cannabinoids that are becoming more and more concentrated in some of the materials that are out there.
I think that's a wise idea.
Yeah.
So just one question, and when you talk about other techniques with the mass spec, are you talking about in-source hydrolysis?
No, we're looking more like APCI techniques.
Okay. Mm-hmm.
And we were looking at obtaining a mixed mode ionization source that can do ESI and APCI that can function in a little bit of a mix of the two so that it's at least a little softer of an ionization, but gives you the extra jolt of the APCI to help with the suppression that we see with our postmortem samples and fatty blood.
Understand. All right, next. I'm sorry, if there's no other questions for the rest of the subcommittee. Next.
All right. The next one is starting to be kind of a catch-all for some of those other older methodology we have for the GC mass spec. This is miscellaneous basic drugs. This includes drugs like quetiapine, hydroxyzine, and a handful of other drugs that are a little bit more troublesome with our older methodology. And so we're going to try to combine multiple methods into one method, utilizing the LC tandem mass spec. This method is actually not being validated here in our research section. This method is being validated in our Roanoke laboratory by the staff out there.
Okay.
All right. And
one question. I'm sorry, Jim. One question. Is this a defined list you're going to work off now, or is it going to be using like ion trap or top technology?
This is a defined list of compounds currently. I believe there's 5. You happen to have them off the top of your head. So I'm looking at Dr. Wagner. But the idea being that this would be sort of a base method we could build off of and add more drugs into it if necessary.
Yep, got it. Okay, go on.
Okay. And the last one is pretty straightforward. It's just the quantitative addition of fluelprazolam to our current benzodiazepine method. We've seen an uptick in detection of fluelprazolam across the state. And so we wanted to be able to quantitate that to start to get a better understanding of concentrations and how they can impact individuals in the DUI realm.
Okay, so this is not about your plan. I think it's a good plan, but what concentrations do you think you're seeing?
They're pretty low level as far as, I think estimates that we're seeing is at the lower end of our concentration range, potentially from anecdotal type of things that potentially at or below the concentrations we're seeing for alprazolam in drivers. Again, we don't have a current quantitation method, so it's really hard to assign a value to it. So it's just anecdotally. We suspect that it's going to be slightly at alprazolam, if not lower.
Okay. All right, any questions on that method plan? All right, are there any recommendations for any of the proposed development work? Hearing none, I will ask a motion to close the review of the methods in development.
This is Rich Myers. So
Shy. Second. Thank you. Any further discussion? Hearing none. Ms. Taylor, could you have a roll call, please?
Maureen,
Aye.
Dr. Edinburgh,
Aye.
Dr. Levine,
Aye.
Rich,
aye.
Jamie.
Aye.
The motion passes.
All right. The next item is public comment, if any. Any members of the public on the call? Okay. Thank everybody for your time, and I guess we'll see you tomorrow. If I could get a motion to adjourn.
This is Jamie. I move to adjourn.
Second.
Rich Myers, second.
No further discussion. Ms. Taylor, roll call, please.
All right, Maureen,
Aye.
Dr. Edinburgh,
Aye.
Dr. Levine,
Aye.
Rich,
Aye.
Jamie.
Aye.
Motion passes.
All right, the meeting is adjourned. Talk to you all tomorrow. Have a good afternoon.
All righty.
Thanks.
Thanks, everyone.